Chapter 2 Basic Concepts of Programming. Concept note: algorithms are the fundamental building blocks of problem solving in computer science. They provide a structured approach to breaking down complex tasks into manageable steps. Learning outcomes: children will be able to understand basics of algorithms and flowcharts, understand the importance of algorithms and flowcharts for computer programming, learn about computer languages and types of language translators. Neha: Hey Tia, I have always wondered, how do computers know what to do? Tia: Great question, Neha. Computers know what to do through programs. Neha: Programs? What are programs? Tia: Programs are a set of instructions that tell a computer how to perform tasks. These programs are also called software. Neha: I see. So, who creates these programs? Tia: Programs are created by computer programmers or software developers. They write lines of code using programming languages. Neha: But how do programmers write these instructions? Tia: Programmers use a combination of algorithms and flowcharts to design these instructions. Neha: Tia, please tell me more about algorithms and flowcharts. Tia: Okay Neha, let's get started. Computers rely on the instructions provided by users through programs. These programs are step-by-step instructions that guide computer to perform certain tasks and operations on given data. Computers follow an input-process-output (IPO) cycle to execute these instructions. Input: in this phase, the computer accepts input from the user. This input could be text, numbers, commands, or even signals from sensors. Process: after obtaining the input, the computer processes the data according to the instructions given in the program. This processing involves calculations, data manipulation, comparisons, and other logical operations. Output: once the processing is complete, the computer generates output based on the processed data. In other words, we can say that programs serve as the communication bridge between humans and computers. Algorithms and flowcharts are essential tools in the process of creating new programs, particularly in the field of computer programming. Algorithm: an algorithm is a step-by-step instruction that shows how to solve a specific problem. It is a sequence of steps needed to perform a given task. Algorithms are a way to solve problems in a structured manner by breaking them into smaller steps and executed in a sequential order. They are used in various fields including mathematics, computer science, engineering, and everyday decision-making. Algorithms can be represented in various ways, such as English-like written instructions, pseudocode, or flowcharts. Programmers use algorithms to design the logic and structure of their programs before writing the actual code. Algorithms comprise simple steps that can easily be understood by a user. For example, the step-by-step procedure of making vegetable sandwich will be as follows. Step 1. Take 2 slices of bread, tomato slices, cucumber slices, onion rings, and green chutney. Step 2. Spread a layer of green chutney on one or both slices of bread. Step 3. Place a few slices of tomato, cucumber, and onion rings on top. Step 4. Sprinkle a pinch of chaat masala and salt over the vegetables. Step 5. Carefully close the sandwich by placing the second slice of bread on top of the layered vegetables. Step 6. Cut the sandwich diagonally to create halves. Step 7. Your delicious vegetable sandwich is ready to be enjoyed. The step-by-step procedure to make a sandwich can be understood as an algorithm. Characteristics of a good algorithm: precision. Precision means that each step should be clear and understandable. Uniqueness. The results of each step are uniquely defined and depend on the input and the result of the previous steps. Finiteness. The algorithm should terminate after a finite number of instructions. Input. An algorithm should have well-defined input parameters. Output. An algorithm should produce correct outputs for all valid inputs. Writing an algorithm. Writing an algorithm involves creating a step-by-step set of instructions to solve a specific problem or achieve a particular goal. Let us take some examples to create algorithms. Algorithm 1. Adding two numbers. Step 1. Start. Step 2. Take two numbers as input. Let us say the first number is 10 and the second number is 12. Step 3. Calculate the sum of two numbers. Sum is equal to 10 plus 12. Sum is equal to 22. Step 4. Print the result as 22. Algorithm 2. Finding the greater of two numbers. Step 1. Start. Step 2. Input the values of A and B. Step 3. If A is greater than B, then go to step 5. Step 4. Else print B is greater, go to step 6. Step 5. Print A is greater. Step 6. Stop. Flowchart. A flowchart is a pictorial representation of steps for solving a particular problem. It can also be defined as a diagrammatic representation of an algorithm. It breaks down an algorithm into individual steps and shows how these steps are interconnected. To create a flowchart, different shapes are used that are connected with each other. Let us describe some of the shapes with their symbols as follows.
Name, terminal box or start or stop box. Symbol, description. It is used in the beginning and ending of a flowchart. Input or output box. It is used for taking inputs and giving results in a flowchart. Process box. It is used to write the instructions for processing. Decision box. It is used for checking any condition in a flowchart. Flow lines. These lines are used to connect the symbols. The arrows indicate the direction of the flow of a program. Connectors. These are used to connect one part of the flowchart to another.
Guidelines for making a flowchart. The rules that tell you how to draw a flowchart are as follows. Make sure your flowchart is easy to understand and conveys information clearly. Keep your flowchart tidy and organized. Maintain the flowchart direction from top to the bottom or left to right. Avoid the intersection of flow lines as this can lead to confusion. Ensure that only one flow line enters a decision box. Ensure that your flowchart has a clear beginning and ending. If your flowchart becomes too complicated, it is better to use connectors to link different parts together. Creating a flowchart. Let us see how to create a flowchart. Calculate the sum of two numbers. Start. Take two numbers A and B. Add two numbers A and B. Display the result. Stop. Difference between algorithm and flowchart. Algorithms and flowcharts are two different essential tools in programming and problem solving. Both help to solve complex problems by breaking them into simpler steps. Algorithms provide logical instructions for solving a problem, while flowcharts visually represent these instructions in a graphical format. An algorithm is a step-by-step method written in simple English, while a flowchart is a graphical representation of those steps. This combination of textual and visual representation helps in understanding and developing complex programs more effectively. Solving problems using algorithm. Imagine you are driving and suddenly your vehicle starts making a strange noise. At first, you might not know how to solve the problem right away. The first thing to do is to figure out from where the noise is coming. If you cannot solve the problem yourself, a good idea is to take the vehicle to a mechanic. The mechanic will check the problem to identify the source of the noise, decide to fix it, and repair the vehicle to get rid of the noise. The above example shows that solving problems often requires multiple steps one after another. When problems are easy, they can be solved quickly, but when problems are complicated, it is important to use a step-by-step method to find the best solution. Basically, you need to use special problem-solving techniques to deal with difficult problems. Computer languages. Humans communicate with each other through spoken language, written words, facial expressions, and gestures. However, communicating with computers is a bit different. Computers don't understand our words directly, so to interact with them effectively, users require a special way to share commands and understand the outputs. This special way is called binary language. Binary language is made up of two symbols, 0 and 1. In binary, these two symbols represent something like on and off for computers. Using this code, we can directly communicate with computers. However, remembering each instruction in binary can be tricky. This challenge led to the creation of programming languages, which make it easier for us to talk to computers without needing to remember all those zeros and ones. Primarily, there are two main categories of computer languages, namely low-level language and high-level language. Low-level languages. Low-level languages are the basic building blocks of computer instructions. They are also known as machine codes. Computers don't understand instructions in English or any other human language. Instead, low-level languages consist of instructions that computers can easily understand. Their primary function is to interact with the hardware of the computer. High-level language. High-level languages are easily understood and written by humans. These languages are user-friendly compared to low-level languages. They use natural language elements which makes it easier for programmers to use. Examples of high-level languages are Python, Java, C++, etc. Tech Corner. The program written in high-level language is called source code. The source code converted into machine code is called object code. Language translator. In computer programming, we use high-level languages to talk to computers. But computers understand only binary or machine language. So to communicate with computers, we need to convert high-level language into machine code. This conversion is doing using translators. Types of language translators. There are mainly three types of translators which are used to translate different programming languages into machine equivalent code. Assembler, compiler, interpreter. Assembler. An assembler translates assembly language into machine code. Assembly language uses mnemonics and symbols to represent machine-level operations. For example, ADD for addition, MOV for moving data, etc. Compiler. Compiler is a program that translates programs written in a high-level language into machine code. It takes the entire program written in high-level language and converts it into machine code at once. If there are errors in the code, the compiler provides error messages that describe the problem and indicate the line number where the error occurred. Interpreter. An interpreter is also a computer programmer that translates the program written in a high-level language into machine code. It reads a line of high-level code and translates it into machine code and executes it line by line. As the interpreter analyzes every line one at a time, it is slower than the compiled programs. Checkpoint. Compare and contrast high-level languages with low-level languages. Flashback. Computers follow an input-process-output IPO cycle to execute instructions. An algorithm is a set of rules and instructions for solving a problem. Flowchart is a pictorial representation of steps. There are two types of computer languages, low-level and high-level. Assembler, compiler, and interpreter are the types of language translators. A translator is a computer program that translates a high-level program into machine code. A compiler translates code written in high-level language into a machine code at once. An interpreter is a computer program that translates program written in high-level language into machine code line by line.